actually, gallium's a little bit like aluminum. Oh, we got it. We got gallium. Let's go. Okay, I have gallium, so I should have known that. I should have known that, guys. I'm sorry. Gallium. Gallium. I'm so sorry it took this long. Oh my gosh, gallium. Gallium. It's taken half an hour, but we made it. Welcome back. I'm That Chemist. Somebody in the Discord asked if I would make a video filling in the periodic table for memory. And I thought that that was kind of a fun video idea, so that's what I'm going to do right now. So there's this song that I learned when I was an undergrad, and it was the first 10 elements of the periodic table. And it goes something along the lines of, do you know the first 10 elements of the periodic table? There's hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. And so once I learned that song, I just added 2 additional verses for the next 20 elements. So let's fill in the ones we've covered so far. Hydrogen, helium, lithium. We have beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Then we have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. Okay. Then we have 2 more. We have potassium and calcium. Now, beyond here, we have the transition metals. So we have scandium, titanium, vanadium. Scandium, titanium, vanadium, chromium, manganese, iron. Now I'm kind of struggling here. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. Okay. Now beyond here, we're going to get a little bit chaotic. So I know underneath silicon is germanium, and then we have tin. Now underneath phosphorus, I believe we have arsenic, and then I think we have bismuth. And I only know that because there was somebody in one of the research labs I was working in who was making these inorganic bismuth complexes based on similar chemistry that they had done with phosphorus. Bismuth might actually be 1 lower. I'm just trying to remember what's below arsenic. I'm going to undo bismuth for now. I'm pretty sure it's a different one, but I'm not 100% sure. We can come back to that one later. Okay. Now let's go back to the main color. Underneath sulfur, it's easy. We have selenium. I have worked with selenium before, and then we have tellurium. Underneath chlorine, we have bromine, and then iodine. Then in the noble gases, underneath argon, we have krypton, xenon, and we have radon. Now, for the alkali metals, underneath potassium, we have rubidium. Then we have cesium, and finally we have francium. Now, it's going to get pretty challenging with the remaining ones. So I know we have strontium and barium. I'm not 100% sure if it's strontium first, but I think it is. And then we have barium like this. I think that that's right. I'm not 100% sure. Underneath copper, we have silver. And then we have gold. Now, that arsenic bismuth thing is driving me crazy because I'm thinking that there's another one. I just can't remember. So underneath silicon, germanium, tin. Oh, this is hard. Okay, so I know that underneath iodine we have astatine, so we can do that one, AT. I think underneath radon we have oganesson. And I know somewhere we have tennessine, but I don't remember if that's like 117, 116, or 115. Okay, I feel like we're doing okay so far. So I think underneath iron we have ruthenium, but I'm not 100% sure. I kind of feel like that should be 1 row lower. Nickel and iron are both ferromagnetic. I think underneath zinc we have cadmium, but I don't remember if it's D4 or D5. Oh, this is so hard. I'm going to say that underneath zinc is probably gonna be mercury. It's quicksilver. Maybe it's so quick that it's right next to silver. I feel like that's wrong. I feel like mercury has to be closer to gold than it is to silver. Okay, we're gonna put cadmium here, and then I think we're gonna put mercury underneath. Okay, my rationale here is mercury likes to form +1 and +2 salts. So if we ionize a D10 metal, it should actually oxidize electrons out of the s orbital. So mercury tends to form mercury 1+, and so that would give it a full D shell and a half-filled s orbital. But it also likes to form mercury 2+, and so that would be like both of the electrons in the s orbital being oxidized. Okay, so we're not doing terrible here. I think I could probably be doing better. Somewhere around here is technetium. I think it's probably underneath vanadium, but it could be like one to the left. I'm not 100% sure. Okay, so what else do we have here? This is hard. You just take it for granted that you know where everything is, but then you need to look, and yeah, you're on the spot here. It's driving me crazy. I definitely know the one between zinc and germanium. I'm just drawing a blank right now. Let's just go through all of the elements that I can think of that we normally see in organic chemistry. We have boron, oxygen, nitrogen, carbon, hydrogen, sulfur, selenium. We have arsenic already. This is pretty hard. This is actually pretty challenging. I feel like it's got to be bismuth there, right? It's got to be bismuth. It's got to be bismuth. I know lead is around here somewhere. I'm just not totally sure. I, roughly speaking, recall silver being fine, a bunch of toxic ones, and then bismuth is just kind of like, hey guys, welcome back to the bismuth. But if it's like boron, aluminum, something lead, I feel like that lead is wrong. I feel like lead should be down a row. Plus lead has a density similar to gold. So I feel like this is where we're going to put lead. But I also don't remember lead being right next to mercury. So I'm like kind of sketched out about the whole lead thing. I don't know. Lead is weird. Plumbanes. So plumbanes behave similar to carbon, right? You have tetraethyl lead. So I'm actually going to put lead here, because you tend to have 4 substituents the same way that you do with tin or germanium or silicon or carbon. But that makes this column even less certain, because what the heck is underneath aluminum? It's one of those weird metalloids, but I'm drawing a blank on what that is. Oh, that's driving me crazy. Oh my gosh. Okay, I'm going to go crazy if I try and think about that one anymore. Okay, so iron, we have ruthenium. We have got to have palladium somewhere. Now, if I think about palladium, palladium tends to be happy in its ground state. So PD0. That means that it's probably got like an S1D5, but that doesn't really explain why it would form palladium 2 species and not palladium 1. So palladium's pretty happy with whatever it's doing. Maybe palladium is where cadmium is. Okay, I'm pretty sure palladium is actually where cadmium is. That would make a lot more sense about why palladium is the hoe of chemistry, being happy in many different oxidation states. So why don't we do that? And if we have palladium there, then that would mean that we have platinum below it. So what did we have here before palladium? I'm just going to Control Z to cheat and Control Y to uncheat. Then we're going to put cadmium here. Then that would mean that we would put mercury here. And then I guess that means that platinum has to go below that. So why don't we do that? So, you know, we got the noble metals, platinum, palladium. I think this is right. And if it's not right, I'm going to be really sad after. Gold, platinum, mercury. So this would be a different rationale for why mercury ionizes the way it does. It would oxidize off an F electron to form mercury plus. Then it's got a full D shell and a full S shell, so it's still happy. But then you'd still be able to oxidize off one of those S electrons. I would think that you could form mercury 3 salts then, but I'm not totally sure. So I can think about some metals that haven't been picked here yet. We are missing rhodium. We are missing tungsten. Let's see, tungsten. I think tungsten might be underneath scandium, but I'm not sure. I know tungsten's somewhere on the left part of the periodic table. We're missing... No, we have magnesium. Oh, this is so hard. Okay, we have europium missing. We have neodymium. That's going to be one of the lanthanides or actinides. We're missing radium, so I guess radium would go underneath barium. That makes sense. We have oganesson we're missing. No, we already did oganesson. We have tennessine we're missing. Okay, this is like pretty hard. We have actinium and protactinium, so, you know, actinides, lanthanides. Protactinium, I think, is... I don't actually remember what the symbol is. Maybe it's PR. Okay. This is hard. This is pretty difficult. We're missing uranium, plutonium. Those are going to be radioactive ones, right? I think that the spots on the periodic table that are like blank are here. I'll just like fill that in with a different gray color. These are the spots where the actinides and lanthanides. Is it lanthanides and actinides? I think it's lanthanides and actinides, right? So I should probably fix that. But man, like, I thought I'd do a little bit better than this. I'm a little bit disappointed in myself, if I'm being completely honest. Lanthanum, actinium. I think protactinium is like 2 over. But I'm actually starting to have to think about which ones behave certain ways chemically. We're getting to like Mendeleev moments here where we're actually thinking about chemistry instead of just doing this off of memorization. Okay. That's a pretty good job erasing, right? I think we're probably good with that. Okay. Chromium. What's underneath chromium? I still feel like ruthenium isn't a D4 metal. It must be D5. So why don't we also do that? Oh no, that's not what we want to do. There we go. Nope, still not great. Okay, can we do that? What if we do this? That's almost right. Okay, there we go. So we're going ruthenium here. What are some other precious metals? We have cobalt. We got nickel. It's driving me crazy that I'm missing whatever element 31 is. Like, I should know what element 31 is. That is driving me crazy. Okay, so we all know that this last row of the periodic table is the one no one really cares about. Some other ones that would be there are Einsteinium. I'm guessing that Einsteinium is an ES, but maybe it's an ET. There's europium. We have europium here. I think europium is a lanthanide, but I don't remember where it goes. We have other ones like berkelium. What are some of the other ones named after places in California? Berkelium is named after Berkeley. I remember that. There's Rutherfordium. I know oganesson is Yuri oganesson. Moscovium is another one. I don't remember if it's an MC or an MS. Moscovium, that looks like more right. You know, we're getting pretty close though. We're doing okay. I definitely should be doing better on the transition metals. I apologize in advance. Now, what the heck is under nickel? I should know what's under nickel. I used to have a periodic table right behind my computer monitor, but I got rid of it because I thought I was going to put it above where the scale goes before I decided to get a whiteboard. So the only periodic table I have is out of sight behind me, and I refuse to turn around to look at it because that would be cheating. Okay, tennessine was either 115 or 117. I remember that 116 and 118 were basically decided, but 115 and 117 were decided as well. I'm going to say that tennessine was like here. I don't remember what the other two new ones were, though. There's tennessine oganesson. Nihonium was the one named after Japan. I think that was the other one here. But I don't remember what the last one was. So we're doing okay. We're doing okay. Definitely could be doing better for the transition metals. I know tungsten is one of the transition metals. Rhodium is one of the transition metals. I'm just drawing a blank here. It's like crazy. I can't remember what the heck that element is. We have copper, zinc. What the heck is next? I'm just trying to think like germane, silane, toxic gases. cadmium toxic, palladium somewhat toxic. But what the heck is to the right there? I'm also still not 100% sure that palladium and platinum are where they belong. I think they might be to the left, right? That would make sense. The s electrons have been fully brought up into the d orbital, so they don't really care too much, but then you could still maybe oxidize them more. But I think it makes more sense that the reason they react the way they do is they're right at the end of the transition metals. I know with chromium, we have those weird carbonyl complexes, so maybe we have molybdenum. I haven't used molybdenum yet. Molybdenum must be under chromium or manganese. Molybdenum could be underneath iron. I feel like molybdenum is going underneath iron, but I'm not 100% sure. Molybdenum somewhere here. Okay. Tungsten. I feel like tungsten was under chromium. It's pretty dense. I'm going to put it here. Why don't we erase this? And then rhodium, it's a noble metal too. I feel like rhodium was probably near ruthenium. Why don't we put it here? Okay, so we settled rhodium. I have rhodium twice here for some reason. So yeah, thank you to whoever in the Discord suggested this. I think this is a great idea for a nice lazy video to pad some watch time on the second channel. I got most of the videos I needed to get done this month, so I'm pretty happy about how the month's going as a result. Okay, so we've got still the second rhodium here. Okay, so uranium's got to be around here somewhere, right? I'm guessing uranium is here. I know uranium to plutonium involves 2. Like if you went from uranium 238 to plutonium 240, I believe. So why don't we do that? Then we can get rid of these ones. Okay, europium is got to be a lanthanide. Not totally sure where it's going to go. I bet it's somewhere in the middle, like, then we can get rid of that one. Neodymium's another early one. I think neodymium is a lanthanide. It's got to be like number 2 or 3. So why don't we put it in 3 just to be safe? We got rid of tennessine, so we can get rid of that as well. And then there's a bunch that are just named after random scientists. So I'm just gonna put those ones in randomly, more randomly anyway. So why don't we just put in some of those, like BK for berkelium, mendelevium. We have, oh, there's that one that has a mineral named after it in California, but I don't remember what the heck that element's called. I've watched a lot of periodic videos at this point, guys, so I know something about most of the elements. It's just driving me crazy that I can't remember what goes here for the life of me. What the heck is that? Moscovium. I feel like that's got to be a relatively earlier one. Why don't we put moscovium somewhere like here? Laurentium is another one. Like for the Laurentium, that's got to be an LR. It's not Lawson's reagent. Berkelium, Einsteinium. Einsteinium would be an earlier one too. Why don't we go like this? Einsteinium. Okay. So I think that takes care of those. Then it's just a matter of making sure we're not missing any elements. So I think this is the best way to do it at this point. Praseodymium is another one. I don't remember what the symbol for praseodymium is. Maybe it's PS. Praseodymium. Praseodymium is another one no one really cares about, so I'm going to do that somewhere around here. Okay. Yeah, this is a challenge. This is a real challenge. We have chromium. There's some weird alloys that have other metals that are interesting. Technetium, I think, is in the right spot, but underneath titanium or scandium, I'm just really drawing a blank. I know that whatever's underneath aluminum is going to be one of those silicon ones that people care about that I just cannot remember for the life of me. We got germanium, we got silicon. Like, what the heck is it? What is it? I can't remember. Maybe if I think harder about this. So mercury behaves electronically similar to silver. So maybe mercury isn't that low down. Mercury, I feel like, is closer to silver. Not too sure. I think even bismuth is in the wrong row. I still think bismuth belongs like here. So then what the heck goes there? I'm pretty sure it starts with like an A or something, but I don't remember for the life of me. How can I just completely forget about some of the earliest metals here? Like, I know rubidium, strontium, but then what the heck comes after that? I think titanium chlorides, scandium chlorides. This is hard. I feel like mercury has to be in the second row, but I'm not 100% sure. It's the cadmium I'm not sure about. I know lead and cadmium are electronically similar. They should be in the same row. Here's what we should do. Why don't we replace cadmium and switch it with mercury? Okay, so we're going to do that. We got lead, we got mercury here, and we've got cadmium. And the reason I say that is we had looked at using mercury for some of our chemistry, and I know in tobacco plants, lead and cadmium are found together. So presumably the similar electronic radii is what makes them get taken up that way. Okay, I feel better about this now. This feels more right. I have no idea what is underneath tellurium. There must be one I'm forgetting. There must be something. There must be another element here that I'm just totally forgetting. I don't know. Or whatever the next one is radioactive, so people aren't interested in it. So iron, molybdenum, ruthenium, that feels right. I'm pretty sure that that's right. Cobalt, rhodium, not as sure. I know that rhodium does carbene chemistry. I'm trying to think of whether or not nickel does any similar stuff to rhodium, and I just don't think so. Wait, no, it's nickel, palladium, platinum. Yes, of course it is. Okay, yes. This is why people try and do similar redox chemistry that they do with palladium and platinum with nickel. Okay, I got this. Okay, this is good. This is starting to go a little bit better. Then that means that mercury and cadmium belong here. Okay, yes, we're making progress. We're making sweet progress. Okay, that feels better. That feels more right. And this column, like nobody cares, right? Whatever's underneath boron, aluminum, nobody cares what this one is. This is the column of shit. Okay, we're doing pretty good now. Okay, we feeling like we're doing okay. Technetium feels right, or pretty close to right. Scandium triflate, titanium chlorides. Oh, this is so hard. Iron, molybdenum, ruthenium feels right. That definitely feels right. Cobalt, what? Then rhodium. Oh, this is hard. Oh, wait. Okay. So I know one, and it's that material that they make fake diamonds out of. I know it's underneath titanium because I was talking to a dentist on Discord a few weeks ago. That is zirconium, right? So ZR either goes there or the one below. I'm going to wager that it goes in second row, not third row, transition metal. We're doing okay. I feel like remembering zirconium, that's a pretty good start. I have no idea what's underneath scandium. I have absolutely no idea what comes after strontium and is below scandium. Chromium and tungsten, that feels right. But what the heck is after technetium? I have no idea. The zirconium chlorides also make sense. I'm like 99% sure that zirconium is underneath titanium. That last row is basically a write-off. Like, we can just fill that in with like random ones. You'd like name a scientist. Like curium, right? Like, is it Cu or Cr? Cr would be chromium, so I guess it must be like Cu for curium. That's an earlier one, right? Curium must be around the time of Einsteinium. I'm going to say curium. No, curium can't be Cu because that's copper. Cm maybe? Cm. Did we do californium yet? Cn probably goes here somewhere too. Californium is probably like, I think that's right. We have tin, right? Have we done tin? Yeah, we've done tin. Okay. What about osmium? Osmium's got to be on here somewhere. Osmium, I feel like, is a second row transition metal as well. Dihydroxylations, oxidize, so it's probably a little bit like chromium or manganese. But where is it? Is it here? It's fairly dense. I'm not sure if it's second or third row, but I'm pretty happy with osmium going there. I'm just trying to think anything, bringing in any chemistry ideas I have. I know with europium, you need europium doping in phosphorescence. What the heck is under scandium, though? I just can't for the life of me remember what's under there. So far, this recording's been going for 31 minutes. I will edit it a little bit just so that all the long pauses are gone. But I have no idea what is going on in this row. So for fun fact, these are the alkali metals. These are the alkaline earth. These are the transition metals. These are the halogens. These are the chalcogens. And these are the pnictogens. And so I'm going to do a PN so you know what I'm talking about. These are the noble gases. I don't remember what the common names were for these two, other than the metalloids are kind of arbitrarily just chosen. Okay. I don't know if I can do much better than this off the top of my head. I know I'm going to kick myself if I don't remember more, especially given that I've like missed some crucial ones here. It's just like I am convinced that there must be another one after arsenic before bismuth. But what is it? Arsenic, Paris green, bismuth, peptibismol. Bismuth being in this row feels right because bismuth has a similar density to gold. It's also a weird one that it's non-toxic. So whatever this is toxic. Whatever this is here is going to be toxic for sure. So if I think about toxic metals, I think about heavy metals, cadmium, lead, mercury. Cadmium, lead, mercury. Maybe mercury does go there. I don't know. Like, then what the heck comes after silver? I don't know. This is hard. This is hard, guys. We have aluminum salts, copper salts. What if I start thinking about radioactive labeling stuff? Can I think of any weird metals? I had one for a second there. Gallium. I feel like gallium is here. Okay, we got gallium. I'm pretty sure that's right. Actually, gallium's a little bit like aluminum. Oh, we got it. We got gallium. Let's go. Okay, I have gallium, so I should have known that. I should have known that, guys. I'm sorry. Gallium. Gallium. I'm so sorry it took this long. Oh my gosh, gallium. Gallium. It's taken half an hour, but we made it. Okay, so what the heck is like gallium then? Before tin? I have no idea, guys. I have no idea. Gallium and aluminum similar. There's another metal though. Like, what is it? What's the metal underneath that's similar? Oh, this is hard. This is hard, guys. I feel like I'm doing pretty good though, okay? Like, I feel like overall, I at least get like a C. You know, I probably deserve a C here. The worst part is I've trained undergrads that have memorized the whole periodic table. So if you're out there and you're one of those undergrads, hey, you're beating me. Oh, this is hard. Okay, let's think more about transition metals. So what is under scandium? It's like another metal nobody cares about. We've got zinc, right? So what the heck is that? What is that? What goes there? I know scandium and strontium are both used in cyclization reactions, although you can also use silver, so I guess that doesn't say too much. Oh, this is so hard. What's the name of that place in California? There's like some mine in California where one of these was discovered. One of these elements was discovered in some specific place in California. I don't remember what it is though. Tennessine, oganesson. Okay, at this point we're going to call it. I will save the file now, and that is that. Okay, now I will open up a picture of the periodic table, and we will see how we did. Any of the ones I got wrong, I will correct in red. Okay, we'll do row by row. So hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. We get a check mark. Good job. Good job. Okay, we get that one. Nice. Beryllium, magnesium, calcium, strontium, barium, radium. Nice. We got that one too. Next we have scandium, yttrium. No, yttrium. Okay, we have lanthanum and actinium, right? So that's good. Titanium is right. Zirconium is right. We have hafnium. Who knows what hafnium is even for? I don't give half a crap. Rutherfordium is here. Rutherford. I forgot about Rutherford. Okay, vanadium is right. But underneath vanadium, we do not have technetium. That one is a couple over. So this is where TC was supposed to go. Underneath manganese. Here is where we have molybdenum. And then to the right of technetium is where ruthenium actually belonged. So this is ruthenium, guys. This is where ruthenium was supposed to go. And osmium was right here. We were so close. And we had rhenium. Yeah, rhenium's a weird one. Super duper weird one. But we got tungsten right. So I feel pretty good about that. But we have tantalum. That's like another one nobody cares about. So that's why I didn't remember. That's okay. Dubnium. That's the other one. Russia in Dubna. I remember that now. Seaborgium. I've even seen the videos of Seaborg. I should have known that. Then we have borium. Then we have hassium. HS. Meitnerium. Yes. Darmstadtium. It's another one for Russia, I believe. I don't even know what RG is. Rogentium. Okay, I didn't even know that one, actually. I feel pretty bad for not knowing Rogentium. Then we have Copernicium. Nicholas Copernicus, yes. Nihonium, which is over here. I was just completely wrong about where that one was. Then we have Fluorovium, Moscovium, Livermorium, Tennessine, and Oganesson. So I got Oganesson, so I guess that counts for something. Above, we have polonium. I forgot about polonium. But guess what, guys? I was right about bismuth, and I was right about lead. Indium is one I forgot. I actually have indium as well, which is kind of dumb that I didn't remember that. And then thallium, another toxic metal. Underneath arsenic, antimony. I forgot antimony. I've worked with antimony too. Okay, what else are we missing? Rhodium was missing. Rhodium actually was second row. And then beneath rhodium, we have iridium, like iridium photocatalysis. How could I forget iridium? Oh my gosh. Okay, let's just double check that we got these all right. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Then we've got zirconium, niobium. That's a weird one. Why don't we ever talk about niobium? Then we've got molybdenum. Oh, wait. Zirconium was right. Sorry, zirconium was right. I apologize. Niobium goes here. Moscovia or molybdenum, technetium. Okay, we got those ones. Underneath nickel, palladium, platinum. My reasoning was right. Silver, gold, right? Cadmium and mercury were backwards. No, I was so close. Cadmium and mercury. So close. Then we'll go through the remaining white ones for the last few rows, and we'll just check that they're right. So bismuth, boron, aluminum, gallium. Yes, I was right about gallium. I did not disappoint. Then we got carbon, silicon, germanium, tin, lead. That's right. Interesting. I was good with that reasoning. I'm impressed. And then I think we're good for the rest of these ones. Okay, now we have the lanthanides and actinides. We have lanthanum, praseodymium. So I was just wrong about this one. Neodymium I got right. Sweet. Wait, is it? Okay, promethium. Forgot about promethium. Then we have samarium, like samarium iodide. Yeah, I should have got that one too. Europium, I was almost right. I was only off by one. It's like pretty good. Gadolinium. Then we have, I don't even know what that one is. Terbium. Oh yeah, terbium. I didn't even think to sing the Element song. I should have friggin' sung the Element song. I totally forgot about that. Wait, did we forget cerium? Oh crap. Okay, so all these are off by one. I'm gonna need to undo the last couple though that we just did here. Okay. There's an issue with the one I was looking at. I was pretty close. Okay. So we have cerium. And to do the one underneath as well. Thorium, like the nuclear reactors. Just totally forgot about thorium. Okay, now we have praseodymium. I wasn't right about neodymium, but I was close. Then we have praseodymium. No, we have promethium, sorry. Then we have samarium. And that means I was right about europium. So I was actually right about one, guys. I did it. Gadolinium, terbium, dysprosium, holmium, erbium, thulium. We have ytterbium and lutetium. All elements pretty boring. Then we have thorium. Protactinium was right, but I spelt it wrong. It should be PA. Then we have uranium, correct, I'd like to say. Neptunium. Plutonium was right. Americium for America. Yeah, that's right. Okay, AM. Then we have californium. Berkelium, Burger Kingium. Wait, what the heck was the first CM? Curium. Okay, I was just wrong about that. Okay, curium. Oops, that's a bit of a long line there. Californium, Einsteinium, fermium, Mendelevium, Nobelium, and Laurentium. Okay, so let's count how many we got wrong. Or ones I just didn't answer. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56. 56. So out of 118, that means that I got 72 correct. Is that right? No, not quite. It means I got 62 correct. That's pretty bad. So I get 62 out of 118. So hopefully this was entertaining, and thanks for watching, and I hope you have a great day.